All right, Algebra 2. Hey guys, welcome to another rip-roaring video. We're officially at video number 2 here. All right, as I told you in one of our Zoom meetings that we will be skipping sections 1 and 2 in chapter 1 and immediately jumping into section 3. All right, so take a look at our notes here. There we go. We're taking a look at section 3 titled Square Roots. And right off the bat, you're going to want to do some things as far as taking notes. Okay, so the first thing you can see on the screen here, you're going to need to copy all 5 key terms from the section. Those key terms are highlighted in yellow. And then I wanted to let you know right here that you are allowed to use a calculator. But in these situations specific to this section, it's when they ask you to estimate a square root. So it's just going to be the simplest. It's okay. You can use the calculator. I know I put this on the Google Classroom as a post that everybody needs to get a graphing calculator, and should be a TI-83 or a TI-84. Let's see if this shows up. See, this is my graphing calculator. This is a TI-83, but the TI-84 works great too. It's actually a slightly updated model, and it'll do everything that I'm going to be requiring you to do. And then you want to get this calculator probably sooner rather than later, but I do want you to know that we can get through nearly all of chapter 1 without it. It's just going to be helpful if you can get it sooner, because then you can start to get used to it with all the features that it has and all the bells and whistles that it can help you with in math. Okay, so let's jump into it. All right, make sure pause the video, rewind the video, all that normal stuff. You got your key terms you got to copy, allowed to use the calculator, and then last piece here, copy the chart at the top of page 22 titled Properties of Square Roots. All right, so you're going to want to pause this video. Go ahead and take care of all those notes. Then we're going to jump into example problems. All right, so let's do some example problems right here. The first one says estimate negative square root of 94. Okay, so you know that because there's a negative sign in front of the radical, that your answer is going to be a negative. Okay, if there's not a negative sign in front of that radical, then your answer should have a positive and a negative representation, because you don't know which one it actually is. But in this case, we have a negative. So let's proceed. Okay, go ahead and plug this into the calculator, make life a little easier. Square root of 94. So you're going to see that those decimals keep going on and on and on. I'm just going to need you to round to the nearest tenth. Okay, so in this case, we're looking at a negative 9.7. So we're rounding that 6 up to a 7. That's our final answer right here. Okay, simple enough. Let's move on. All right, now we are simplifying square roots. Now, simplifying square roots means you do not ever give me your answer as a decimal. Okay, simplifying square roots means that all of your answers will either still have a square root in simplest terms, or you will actually just have a regular number with no radical, but no decimal. Okay, so when I say regular number, we're talking a whole number. Okay, no decimals here. All right, so let's try this first one. We have a square root of 48. We know it doesn't work out perfectly, but that's the point of this. We're simplifying. So what we will use are these little factor trees that takes you all the way back to like pre-algebra, even elementary type level math here. So a factor tree is where you're going to take this number, in this case 48, and you're going to break it down into two numbers that if you multiplied them together, they would equal the 48. All right. And I believe our best situation here is if we were to do 48 divided by, 16, works out perfectly. But you have to make sure that you write your two factors underneath a radical. Okay, the 48 is underneath a radical, so 16 and 3 have to be underneath a radical. All right. Now, what do we do with this? What's the point of simplifying? What do we do with the 16 and the 3? Well, the 3 can't go anywhere. All right. The 3 is a prime number. The square root of 3 does not work out nicely. So we leave the square root of 3. But the square root of 16, that is a perfect root. All right. What does that mean? That means that you can actually do the square root of 16. The square root of 16 is 4. And then we're just going to tag on that square root of 3 right next to it. And that's it. There's your answer. Okay. So simplifying, you'll notice here, we have a whole number, 4, but we still have a radical, and that's radical 3. All right. That's what it looks like to simplify a radical. All right. Let's move on to the second one here. We have the square root and then this fraction, 36 over 16. I'm going to show you the trick, but this isn't so much a trick as it is you guys actually using the charts that you should have already copied down, properties of square roots, okay? And what we are allowed to do here is break up this radical into 2 radicals, all right? So really, this could be rewritten as radical 36 over radical 16, and you should notice something, that radical 36 is a perfect root, and so is radical 16. So square root of 36 is 6. Square root of 16 is 4. So you have 6 over 4. So that's good, but you're not done yet. Why? Because 6 over 4 is a fraction that can be reduced. All right, so what would that become? It would reduce to 3 over 2. All right, so there's our answer for the second one there. Now let's take a look at the square root of 147 divided by the square root of 3. Now, you'll notice in the last one, we took a big radical and broke it down into 2. What if we're given 2 radicals? Could we do the opposite and just say, okay, we're going to put this all under one big radical? Of course, yes, we can. All right, so we're going to take a big radical here and go 147 over 3. Here's why we're doing that. Plug that into your calculator. What is 147 divided by 3? It's 49. Why do we like this? We like this because the square root of 49 is a perfect root. The square root of 49 is 7. Yay. Okay. All right. So those 3 right there works out nicely. Okay. Remember again, rewind, pause the video, do whatever you got to do here. All right. Let's move in. Next group, simplify, but not just simplify. We have to rationalize the denominator. All right. That's a big old fancy phrase that basically means you can never, ever leave a square root in the denominator. You must do what is called rationalizing it. Fancy way of basically saying you're going to eliminate that radical. But how do you do that? By multiplying that radical by itself. All right, so let's take a look. 5 over radical 10. How do we get rid of radical 10? How do we rationalize this? By multiplying it by itself, which means multiply it by another radical 10. And everything in math, what you do to one side, you got to do to the other. So that means we need to multiply the top by a radical 10 also. Now, if you look at that chart, again, you should have already seen this, but if you have a radical and the same thing is underneath that radical, so like this, radical 10 multiplied by radical 10, your answer is just whatever number is under that radical. It's 10. So that means our denominator now just becomes 10. We have eliminated that radical. Okay, so that's good. And now what is 5 times radical 10? Leave it. You don't need to actually figure that out. Here's why. Radical 10 is not going to be a nice radical. You're going to have decimals behind that. Okay, remember, you don't want decimals when they ask you to simplify. Okay, but if you take radical 10 and you break it down, all you can break it down into is radical 5 and radical 2. That doesn't help me even when I do that. And here's why. Because 5 is prime, so that can't go anywhere. 2 is prime. I can't go anywhere with that. So leave it as radical 10. So 5 radical 10. There we go. There's our solution here. All right, now the next one, we got some steps to take. We have a radical 6 in the denominator, but we also have a 2. Okay, treat that 2 kind of like a coefficient. In other words, like if it were in front of a variable. All right, we are going to multiply everything down here by the whole denominator. Okay, so if you're tracking with me in the textbook, by the way, I am now looking at the style of problem that is on page 23. All right, we're taking a look at example 3, where they're saying rationalize the denominator. Okay, so that's what we're doing here. So we will be multiplying the denominator by itself, right? We need to rationalize it. Okay, so let's multiply this another 2 radical 6. Okay, and then again, what you do to one side, do to the other. 2 radical 6. Okay, so here's what we got. We got a 2 times a 2. There's 4. We got a radical 6 times a radical 6. Remember, what does that become? It just becomes the number that was under the radical. So 6. And then we have these two multiplied together. 4 times 6. So that's going to be 24 in our denominator. All right, we're going to need some more space. So let's do this. Let's scroll a little bit. All right, we need to make sure we got that space. Okay, so we know our denominator is 24, but we still have to take care of our numerator. All right, 3 times 2, that's going to give us 6. Then we still have a radical 27, and we still have a radical 6. Okay, let's break these down. How is this going to work? So we will see if we get some more space here. Radical 27, break that down. What could it be? It can be a radical 9 and a radical 3. Okay, we're making a factor tree. What's 9 times 3? 27. But the original 27 was underneath a radical, so we got to keep it that way. Now, what is the square root of 9? Well, that works out perfectly. That's 3. But you'll notice that that square root 3, that's got to stay there. Okay, now what do we have? Let's break down the 6. This breaks down into a radical 3 and a radical 2. Normally, I'd say, well, we can't go anywhere with that. You remember back in the last problem, the radical 10? We didn't go anywhere with it? Well, that's because we had nothing else to combine it with. I see 2 radical 3's that are going to be able to be combined because they are being multiplied together. And go back. What is a radical times itself? Just the number that's underneath that radical. So these guys will make 3. All right, so now what we're looking at is we have a 6, we have a 3, and we have another 3. All of those numbers are outside of a radical, and they're all being multiplied together. Okay, so what we're going to be doing here is multiply all those together. So 6 times 3 times 3. Let's scroll down the page, get a little bit more space here. That's going to be 54. And what is still left over? That radical 2. We got to bring that down. Radical 2. Okay? Now, do you remember what was on the denominator? It was 24. All right? Now, we aren't done, and here's why we're not done, because we can reduce 54 over 24. Okay? So what's the biggest number that can go into those? Let's see. If we were to take just 2 out, that might be the best we could do. Okay? So let's see. If we take a 2 out of 54, that's going to give us 27. Don't forget that radical 2. And take a 2 out of 24, and that's going to get us 12. Looks like maybe we could have done a little better than that. Let's go one more step. Divide each of these by 3. Yeah, I missed one. So 27 divided by 3, that's going to give us 9. And 12 divided by 3, that's going to give us 4. Okay, so now we are looking at the final solution there. 9 radical 2 all divided by 4. Okay, let's see what we are moving on to. The next part here is adding and subtracting square roots. So we're looking at example 4, styles, again on page 23. Okay, so let's move down the page, and we just got 2 more to go. All right, now here's what you like. You like if the square roots are the same number, okay? Think of it like this. If they are the same number, it's just like having the same variable, okay? Can you put 6x with 7y? No, you can't. But you can put 6x with a 7x. So it's the same concept. All right? What is 6 plus 7? 13 with a radical 7 tagged onto the end. Simple as that. All right? Now, take a look at the next one, though. What is different about this is that you got a radical 32 and then you got a radical 2. Clearly not the same number. But what can we do with that 32? We can simplify it. We can break it down. All right, what would the easiest thing to break it down into? I'm thinking radical 16 and radical 2. All right, let's just keep it as easy as possible. Why do we like radical 16? Because radical 16 is the number 4. Works out perfectly. Now I see that I have 2 whole numbers. 2 whole numbers that are being multiplied together. Now, how do I know they're being multiplied together? Because go back to the original. 5 times square root of 32. It's all being multiplied together. So 5 times 4 is 20. Tag that radical 2 down here. Rewrite the rest of the problem. What do you notice? Now you should notice we both have a radical 2. The 20 has a radical 2. The 15 has a radical 2. So because these guys are the same, we can now just deal with their coefficients. What's 20 minus 15? 5. And tag on that radical 2. All right. So there you go, guys. That covers all of section 3 work for you. Nothing else that we need to go through. All the homework will be problem styles, just like you saw right there from the video. And that's it. All right. So thank you, guys. Rewatch, rewind, do what you got to do. You got questions, go ahead and message or wait till the Zoom. All right. See ya.